We're going to talk about how to find the area of a rectangle and a square and then do some example problems. So when you look at your formula sheet, so you don't need to memorize these formulas, they're on your formula sheet, but when you're talking about area, how you can think about that is like if you're going to lay carpet on a floor, that will be the area. If you're going to paint a wall, that's the kind of thing is basically if you're covering something, that's what area means, whereas perimeter means the measurement around an object. Area means kind of filling the inside of the object. And so the units that go with area are always called squared units. So whenever you see something with the units are squared, like feet squared or square feet, square inches, that refers to area. So on your formula sheet, the area of a rectangle, it shows area equals length times width. So it says LW. When those two letters are put together, that means multiplication. L means length, W means width. And so remember, a rectangle has four 90-degree angles parallel. The length, it really doesn't matter which side you call the length and which side you call the width. Normally you call the width the shorter side. So you have length and width. So to find the area, you just multiply those two numbers together. So if this is 10 and this is 4, the area is going to be 10 times 4 equals 40. Let's say this was 10 feet. 4 feet, it's going to be 40 feet squared. That's the units that you write on it, because you're multiplying feet times feet, so that's how you get square feet. Similarly with a square, remember with a square each side is equal length. It's really the same formula, but they write it with an S because each side is the same length. So if this is 10, then this is going to be 10, this is going to be 10, this is going to be 10, and that's what they're calling S, is the side. But it's the same thing. You can think of it as length times width. It's going to be 10 times 10. But the reason they write it as S squared, so here they're saying S equals 10. One side equals 10. So area equals 10 squared. And if you don't know how to deal with exponents, you need to watch the video on exponents. So what does squared mean? It means how many times you're going to multiply this by itself. Since it's 2, it's 10 times 10. It's 2 times equals 100. So S squared, if S equals 10, the side equals 10. It's just 10 times 10 equals 100. But it's really the same formula, because remember the square is just a special case of the rectangle. So if you can't really figure that out, just remember you can still do length times width. 10 times 10. You're going to get the same answer. So a rectangle is length times width. A square really is length times width. It's just that they are the same. So you can think of it as side squared. So we're going to do a couple of examples because this is, fairly straightforward. It's just multiply the two numbers together. But you're probably not going to get a problem on the test that's that straightforward. So we're going to do a couple of examples. So here we're going to say that someone wants to build a bookshelf in an office that is 12 feet by 15 feet. The shelf will go along the entire wall. The bookshelf is going to be 1, so this is a 1 foot deep. which wall should you put it on? Or put it against to maximize floor space. So you're most likely going to get some sort of word problem that you're going to have to read through and think about really what they're asking here. So you want to build a bookshelf in an office, and the office is a rectangle. Is the shape of the office. It's 12 feet by 15 feet. The shelf is going to go along the entire wall, and it's going to be 1 foot deep, is the bookshelf. So which wall should you put it against? Should you put it against this wall, or should you put it against this wall? And so the answers might be against the shorter wall or against the longer wall. So how are we going to figure this out? Well, you want to maximize the floor space. So that's maximizing the area, because remember, when you're filling something in, or the space within something, that means area. So we would just do this by trial and error. Let's just say we're going to put the bookshelf along the shorter wall. Remember, so here's your bookshelf, and it's 1 foot deep. So the floor space is going to be knocked off by a foot because that bookshelf is going to be there. So if we put it against the shorter wall, then we've lost 1 foot of our space here. So the remaining floor space will be 14 feet. If the whole thing is 15 feet and we've lost a foot to the bookshelf, we're left with 14 feet. So now we're really looking at this area in here. It's 14 feet in length and 12 feet in width. So the area is length 14 times 12. And if we do that, you get 168. I'll write it as 168 square feet. So that's if we put it against the shorter wall. If we put it against a longer wall, so I'll redraw this. So this was 12 feet, this was 15 feet. If we put it against a longer wall, let's say we put it against here. Again, this is 1 foot. So now we're looking at this area. How big is this area? Well, we've lost a foot, so now our width is 11 feet. Our length is still 15 feet, so the area is 15 times 11, which gives you 165 square feet. So if you want to maximize the floor space, you want the most floor space, 168 versus 165, so 168 would give you more floor space, and so you would want to put the shelf this way against the shorter wall. So that would be the answer to that question. We'll do another question. You want to cover a table with tiles. The top of the table is 5 feet long and 2 feet wide. Each tile is a square that measures 4 inches on each side. How many tiles do you need? So here we have a table. We want to cover it, so you should be thinking about area. And so the table is 5 feet long and 2 feet wide. And each tile we have is a square with the sides are 4 inches. So the question is, and this isn't drawn to scale obviously, is how many of these tiles do we need to put over to cover this table? So the first thing you want to look at, and this is with any problem you get on the test, this is in feet, this is in inches. So you can't compare the two. You have to get it to the same unit of measure. So the easiest thing is always to change it to the smaller unit. So feet are bigger than inches, so I'm going to change everything to inches. So instead of writing this as 2 feet, there are 12 inches in a foot, so 2 feet is 2 times 12 equals 24 inches. 5 feet, there are 12 inches in a foot, so 5 times 12 is 60 inches. So now we have inches and inches. So how many of these tiles are we going to put on this table? So we can forget about the feet. We have a table that's 24 inches by 60 inches. So the total area of that table is, again, length times width, 60 times 24. You can plug that in to your calculator. And you get 1,440 square inches. So that's the total area of the table. The area of one tile, again this is a square, so we know each side is the same, is 4 times 4 is 16 inches squared. So the total area we have to cover is 1,440. Each one of these little tiles that we're going to put on this table, like that, is 16 inches. So how many of these do we need in order to cover the whole thing? And to do that is you do a simple division. So it's 1,440 divided by 16. And if you do that, you will get 90. So you need 90 of these tiles to cover this table. So this was a bit of a complicated problem because you have to recognize these are feet, these are inches. So you first have to get everything in the same unit. You can change it all to feet, but 4 inches is 1/3 of a foot, so then you'd be working in fractions, which you can if you're comfortable with that. But it's easier to change everything to inches. 2 feet, there's 12 inches in a foot, so you multiply it by 2, 12 by 2, and you get 24. 5 feet, 12 inches in a foot, 5 times 12 is 60. You find the whole area of this table, and now you're trying to put these tiles, which are 4 inches by 4 inches, or a total of 16 inches squared, that's the area of that thing. How many of those will it take to cover this whole area of the table? You just divide your whole area of the table divided by each individual tile, and that will tell you how many tiles you need in total, 90. We're going to do one more problem. You have a swimming pool. And it is, let's see, 50 feet by 30 feet. You're going to put a walkway around it. the walkway is 5 feet wide. Question is, what is the area of the walkway or the sidewalk? So you need to think about, so obviously this is an area problem, so it's always good to draw things out if you can. So here's our swimming pool. It is 50 feet by 30 feet. So 50 feet in length, 30 feet in width. You're going to put a walkway around it. So around the outside you're going to put a sidewalk. And the sidewalk is going to be 5 feet wide. So we're going to draw the sidewalk. And this is 5 feet on each side. So when they ask us what's the area of the walkway, we just want the area of this, like almost looks like a picture frame around the swimming pool. So how are we going to find that? We're first going to take what's the area of the whole thing, and then we're going to subtract out the area of the swimming pool, and then that will give us just what the area of the walkway is. So let's first find what's the area of the swimming pool. Well, it's length times width. The length of the swimming pool is 50, and the width is 30. So the whole area is 1,500 square feet, really. What's the area of the whole thing when we include the walkway? Well, if this was 50 feet, and we added 5 feet on this side and 5 feet on this side, then it's 50 plus this 5 would be 55 plus this 5, which would be 60. So this whole length is 60 feet. If the swimming pool was 30 feet in width and we added 5 feet of walkway down here and 5 feet of walkway up there, it would be 30 plus this 5, which would be 35 plus this 5. So this is going to be 40 feet. So this whole outer rectangle is 60 by 40. I'm just going to say area of the whole thing is 60 times 40 equals 2,400. The question isn't what is the area of the whole thing, it's what is the area of the walkway. So all we really want is what's the area of this part. So how we're going to find that is we're going to take the area of the whole thing, 2,400, that was the whole thing, and we're going to subtract out the area of the swimming pool, which was 1,500. Because when we take the whole thing, subtract out the swimming pool, we're just left with the walkway. So it'd be 900 square feet.